Hello and welcome to this program performance demonstration. The program featured is a lift control system developed by Lawrence Jackson and Farhad Mazari. We started this project with the problem that was presented to us. We then broke it down to 4 main bullet points. It needed to have 3 floors, 4 corridor buttons, 3 lift buttons, and an emergency overweight mode. From here we decided the next logical step was to design the setup for the HCS12 board. We began by using the problem points to create a virtual representation of the system. As you can see, there's 4 corridor buttons, 3 lift buttons, and 3 LED location lights. Using this representation as a guide, the LEDs were placed on the actual board as accurately as possible. However, the location LEDs were moved down to the bottom of the board due to space constraints. However, this also makes it easier to follow the location of the lift. This next clip illustrates how the board is connected up. We start down the centre where a common ground has been constructed. It leads up to that top bar and feeds into the ground on the board. As you can see, on the bottom left, the buttons are connected to our designated input, port A. The output from the microprocessor was allocated to ports B and E. As you can see, all the LEDs on the board are fed from these 2 ports. To fully solve the problem presented to us, we had to include an overweight function. To represent a weight value from a sensor, we would use a potentiometer located on the board. We then had to assign the buttons. Here is the second floor lift button, the first floor lift button, and the ground floor lift button. The second floor corridor, both the first floor corridor and the bottom floor corridor. This short clip demonstrates how we've set out the lift location LEDs. As you can see, floor 2 is at the top and the ground floor is at the bottom. As you move the lift through, you can see the different LED lights up corresponding to where the lift is. As you will see in the next part of this video, this LED location is a key part to this program. We'll now move away from the board setup and focus more on the code and the program itself. Code development started with us simplifying the problem down to a 2-floor system. This allowed us to find out all the functions and the program structure that we needed. Our method was to assign a variable to each floor. As you can see here, we've defined it outside of the main program. Then once the variable became true and the lift was at that location, each button was assigned a certain command, as you can see here. Once the 2-floor system had been tested and perfected, we then added an extra floor and the necessary extra LEDs. As you can see here, there's 3 definitions instead of 2. This section of code shows the function that determines when the lights flash for the potentiometer, the overweight mode, and also shows the ground floor function for one of the buttons, and for when the lift is at the first floor, and finally at the second floor. In order to speed up writing the code and minimise debugging afterwards, template code was produced. There's 3 blank pieces of code that didn't have any of the bits turned on. They were then copied and pasted into the program and the relevant bits turned on. The template idea was mainly used because there is only 3 maximum movements that the lift can make. Stay where it is, move 1 floor, move 2 floors. We now move on to the 3-floor full system test. The first scenario starts with 2 people. One of them then presses the ground floor corridor button and they enter the lift. Now, as many people do when in a rush and using a lift, they press the wrong button and select the ground floor lift button. This just shows that the program will not malfunction, but flash to show the user the lift is already at that location. One of the users then presses the first floor lift button, the lift then moves up to the first floor and one of the users exits the lift. The second user then presses the second floor lift button and the lift carries on and moves up to the second floor and the second user exits the lift. Another user is at the ground floor. They then press the ground floor corridor button and the lift is moved down. Once it is at the location, the user enters. Once in the lift, the second floor is selected from the lift buttons and the lift moves all the way up to the second floor and the user exits. Someone is now on the first floor and presses one of the two corridor buttons, in this case the down button. The lift is then moved to the first floor and the user enters. However, once in the lift, the user changes their mind and selects the second floor lift button. Consequently, the lift takes them to the second floor and they exit. After the previous user exits the lift, someone presses the second floor lift button. The lift is already at this location, so the user enters. Once inside, they press the ground floor button and the lift takes them all the way down to the ground floor. However, before the user can exit, the lift is filled with many people who have a meeting on the second floor. The lift becomes overweight and the LEDs inside the lift flash to warn the users that the lift can't carry this many people. This concludes the system test. These were only a few examples of possible scenarios. The program will function correctly for any combination of starting and destination floor. Shown in the test, the program could also deal with user errors. Thank you for watching this video. For any further information, please feel free to get in contact.